So you're going to see in a lot of my Chem 1, Chem 2 videos, I talk a lot about standard deviations or significant figures. And it is one of those things that, like, when you start teaching, you kind of know what you know in your course, but you don't see how the courses connect. And it's an unfortunate thing because you do need to fundamentally understand the course before you start actually moving to the next course in the sequence. Make sure you understand the lower level stuff before you really get at the higher level stuff. Because I would definitely have taught things that were incorrect. But the shame is, we talk about significant figures a lot in Chem 1 and Chem 2, and I'm guilty of it. I would ping students for it. Not much, but I would ping them for it. But then you go and you take a quantitative chemistry course, and the quantitative chemistry course turns around and says, standard deviations, confidence intervals, all those calculations are what matter. Your Sig Figs are not particularly useful. So students ask, and it's a reasonable thing, is why should we do standard deviations if we're going to turn around in a hiring course and say they aren't useful? It's not that they aren't useful, it's just that we overemphasize them too much. Like naming in organic chemistry. We really harp on naming, and then at the end of the day, there's 4 naming schemes you can use, and there's trade names. It's a mess, right? We have to assess you on something. And we want to make sure when you're in Chem 1, you don't have the skill set to calculate the uncertainty of the confidence intervals on your numbers. But it is fair to say that you shouldn't be giving calculator output either. So the use of significant figures is that if you don't have the time or you don't have the ability to actually go through and calculate an uncertainty on your number, they are a very quick and dirty way of doing it. So an example of this is, let's say you have a pipette and there is an uncertainty on that volume, and it's written on the side of the pipette. It'll tell you plus or minus this volume. The thing is that if you take a single pipette measurement, you technically haven't done the work yet. You really should be taking a bunch of volume measurements and figuring out the actual uncertainty on that pipette. But this is really not practical. And so what we do is that we use the 2.00 on a 2 milliliter pipette and we use that last significant figure to kind of help estimate errors throughout the rest of the way. But we're going to treat those significant figures really represent a level of precision that we simply don't have with the other numbers we're taking. So you might be using a 2 milliliter pipette, but you're creating a bunch of standards, and the errors in those standards aren't really related to the error in the volume, they're related to the errors in the techniques or random errors throughout the procedures. So yeah, if you watch my Chem 1 videos, it's kind of weird and cringy at this point to see how much I emphasize, particularly as a Chem 1 instructor. But the thing is, they aren't entirely irrelevant. They're just kind of there as a quick and dirty way of figuring out. So go back to when you look at textbooks about how to use FTIR, and they talk about using the functional groups. And it's really annoying because functional groups are good for a quick and dirty estimate of what your molecule is, but you would really look at the fingerprint region to figure this out. Significant figures are the same way. They are there as kind of a quick and dirty way to figure out where your answer's reliability is. But in terms of actually figuring it out, you would go through and do a much more rigorous analysis, and you would go through and do it. So again, it's not wrong that we teach significant figures. It's good that we teach it, particularly in Chem 1, to make sure students understand that your answer is not calculator output. You need to go through and kind of figure out the box of accuracy on your numbers, but also realize you're kind of growing up in your chemistry field, and you're learning now about how to do analytical techniques and analytical analysis, and you've got a much better tool set you're supposed to know. Instead of hand waving saying, oh, well, I just add and subtract, your significant figures, you probably noticed, don't handle exponential logarithms very well. What you're learning here will actually help you with that. So again, I'm sorry, especially if you had me and I really harped on significant figures. I'm going to keep doing it for Chem 1, Chem 2 because these don't give me calculator output. But again, we're going to kind of shed that approximation out. Much like we just said, shed Lewis theory as an approximation for MO theory for more nuanced problems, we're going to do the same thing here with statistical analysis.